Hi students, in the last class we discussed about the 15th group elements, that is of about oxides, oxoacids of the phosphorus. From this class onwards we can study about the 16th group element. The 16th group elements are namely oxygen, sulfur, selenium, tellurium, tellurium, and polonium. Oxygen, sulfur, selenium, tellurium, and polonium. These are called as the 16th group elements. It is an oxygen family. These 16th group elements also called as the chalcogens. Why they are called chalcogens means these elements forms the ores. These elements have capacity to form the ores. That is, they occurs in the form of oxides or sulfides. The ores occurs in the form of oxides or sulfides. Hence, they are also called the chalcogens. Next, you consider occurrence. That oxygen is the most abundant. Oxygen is the most abundant element in the earth crust that forms 46.6% by mass. 46.6% by mass of the earth crust. Oxygen is the most abundant element in the earth crust. That earth crust consisting of 46.6% by mass. Then dry air, nothing but the atmosphere. That dry air nearly contains 20.9% oxygen, 20.9% of oxygen by volume. The total atmosphere oxygen percentage is nearly 21%. This is about the occurrence of the oxygen. Then occurrence of the sulfur. Abundance of the sulfur in the earth crust is only of 0.03 to 0.1%. Abundance or occurrence of the sulfur in the earth crust is only 0.03 to 0.1%. In the combined form, in the combined state, sulfur exists as sulfates. In the combined form, sulfur exists as sulfates. Examples are gypsum. Formula is CaSO4 2H2O. This is the gypsum. Or maybe of Epsom. Epsom means MgSO4 7H2O. It is called Epsom. Or maybe of an barite. That barite composition is BaSO4, barite, as well as sulfide ores in the form of sulfide ores like copper pyrite or chalcopyrite. Composition is CuFeS2, copper pyrite, or maybe of galena. Galena composition is PbS, galena, or maybe of zinc blende. Zinc blende composition is ZnS. And traces of sulfur traces of sulfur occurs as hydrogen sulfide. Traces of sulfur occurs as hydrogen sulfide in volcanoes. In volcanoes also sulfur present in the form of hydrogen sulfide. Then organic materials like proteins, organic material like protein, egg, garlic, onion, or maybe air, wool, they also contains the sulfur. Organic materials like protein, egg, garlic, even mustard, onion, air and wool, they contains the sulfur. Selenium and tellurium, they present in the form of their metal sulfides, selenides and tellurides, in the form of metal sulfide ores. And polonium is radioactive in nature. It is obtained by the decay. It is a decay product of uranium and thorium. Polonium is a radioactive element. It is obtained by the decay of uranium and thorium. This is about the occurrence of the 16th group elements. Note down that occurrence. Next you can study about the general characters. Next, consider the general properties. First property is the electronic configuration. That is, first one is oxygen. Oxygen configuration is helium 2s2 2p4, sulfur, neon 3s2 3p4, selenium configuration is argon 3d10 4s2 4p4, tellurium, that is configuration is krypton 4d10 5s2 5p4, polonium, xenon 4f14 5d10 6s2 6p4. By using this one, the general electronic configuration of the 16th group elements is given by noble gas NS2 NP4. Noble gas NS2 NP4. This is the general electronic configuration of 16th group element. You observe that oxygen. For oxygen, valence shell, that is N equals to 2. That is similar to nitrogen. N equal to 2. That nitrogen contains only S. N equals to 2 means then the possible L values are 0, 1. If 0 means it is an S subshell, 1 means P subshell. That is, oxygen not contains vacant d orbital. You consider sulfur onwards. For example, sulfur, that is N value, it is equal to 3. Valence shell contains the 3. N equals to 3 means L equals to 0, 1, 2. That means from sulfur onwards they can provide. L0 means S, P, it is D. From sulfur onwards, all the elements, they can provide the vacant d orbital. But oxygen not provides the vacant d orbital. This is important for next anomalous properties. This is the general configuration. Then next general character is atomic and ionic radius. Atomic and ionic radius or size. Atomic and ionic radius. Atomic and ionic radius increases down the group, that is from oxygen to polonium. Oxygen to polonium, that atomic and ionic radius increases because increase in the number of valence shell, that is electrons entered into the new shells. Due to increase in the number of the shells, that atomic and ionic radius increases from oxygen to polonium. Then next one is ionization potential or enthalpy. Ionization enthalpy. Again, ionization enthalpy decreases from oxygen to polonium. Ionization potential value decreases from oxygen to polonium. Why that ionization enthalpy decreases from oxygen to polonium means due to increase in the atomic size. Atomic size increases from oxygen to polonium. Due to increase in the atomic size, ionization enthalpy decreases from oxygen to polonium. Next one is electron gain enthalpy. Electron gain enthalpy. Electron gain enthalpy. Again, electron gain enthalpy decreases from oxygen to polonium. From oxygen to polonium, electron gain enthalpy decreases. Here one exception, that is actually oxygen atom show very high electron gain enthalpy, but oxygen atom having a small size, due to small size of the oxygen atom, they arise as an high inter-electron repulsion. Due to small size, there is an high inter-electron repulsion. Hence, oxygen atom shows less negative electron gain enthalpy. Electron gain enthalpy than the sulfur. Actually, oxygen has to show more negative electron gain enthalpy because down the group, that is oxygen to polonium, electron gain enthalpy decreases. Electron gain enthalpy generally denoted by the negative sign, negative value. It is liberated, negative value. Oxygen to polonium, electron gain enthalpy decreases, means become more and more less negative. That based on that one, oxygen has to show very high negative electron gain enthalpy compared to sulfur. But if you observe the values, oxygen shows less negative electron gain enthalpy than the sulfur. Why means because of its small size, they arise as a high inter-electron repulsion. Due to small size of oxygen atom and high inter-electron repulsion, oxygen shows less negative electron gain enthalpy than that of the sulfur. This is the exceptional case. That means electron gain enthalpy is in the order sulfur higher, sulfur greater than the oxygen, sulfur greater than that of the oxygen. Actually, oxygen has to show high negative electron gain enthalpy compared to sulfur. Due to its small size, sulfur has high negative electron gain enthalpy than the sulfur. Next, you consider the electronegativity. Next character is electronegativity. That oxygen is the second most electronegative element. Oxygen is the second most electronegative element. That is, fluorine is the highest, more electronegative element. Fluorine is the more electronegative element. Fluorine is the first, highest electronegative. Next to fluorine, oxygen is the second most electronegative element. Then electronegativity value decreases from oxygen to polonium. Electronegativity decreases from oxygen to polonium, indicates that metallic character increases from oxygen to polonium. This is about the electronegativity. Next you study the physical properties. The physical properties, oxygen and sulfur are the non-metals. They are the non-metals, while selenium and tellurium, they are the metalloids. They are the metalloids, and polonium is an radioactive metal. Radioactive metal. Polonium is a radioactive element. Then all the 16th group element shows the allotropy. All the 16th group element shows the allotropy. Then melting and boiling point. Melting and boiling point increases from oxygen to polonium. Melting and boiling points increases from oxygen to polonium. If you observe the melting and boiling points between that oxygen and polonium, between oxygen and polonium, there is a large difference in melting and boiling point. Between oxygen and polonium, there is a large difference in melting and boiling point. Why this happens means that can be explained based on the atomicity. Based on the atomicity, we can explain why there is a large difference in melting and boiling points between oxygen and polonium. Generally, that oxygen is diatomic. Oxygen is diatomic, while sulfur is polyatomic. Sulfur is polyatomic, that is octatomic in nature. Oxygen is diatomic, sulfur is polyatomic. Due to that difference in their atomicity, there is a large difference in melting and boiling points between the oxygen and the polonium. Next, you consider the oxidation state. These 16th group elements exhibit number of oxidation state. For example, oxygen shows -1, +1, -2 and +2. Sulfur exhibits -2, +2, +4, +6. Sulfur, selenium and polonium, they can exhibit the same oxidation states, -2 to +6. Sorry, this is tellurium, selenium, tellurium. Then polonium exhibit only +2 and +4. +2 and +4. It is the oxidation state. That stability of -2 oxidation state, stability of -2 oxidation state decreases down the group. Polonium not shows -2 oxidation state. Polonium not show -2 oxidation state. Why it not show -2 means because of its metallic character. Polonium is metallic in nature, hence it not show -2 oxidation state. Due to high electronegativity of oxygen, oxygen generally shows the negative oxidation state of -2. Due to very more electronegative nature, oxygen show always negative oxidation state of -2, except exceptional cases, except in case of OF2. In OF2, oxygen shows +2 because fluorine is more electronegative. Then O2F2. In O2F2, oxygen shows the +1 oxidation state. And in H2O2, oxygen shows the -1. That is in peroxide. In peroxide, it shows the -1. and in KO2, that is superoxide. In KO2, it shows the minus of. This is an superoxide. In peroxide, minus 1. In superoxide, minus 1 by 2. In O2F2, plus 1. In OF2, it is of plus 2. This is the oxidation state. Other elements exhibit plus 2, plus 4 and plus 6. Plus 6 oxidation state. The stability of the plus 6 oxidation state decreases and plus 4 oxidation state increases down the group. Stability of plus 6 oxidation state decreases and plus 4 oxidation state increases down the group due to that of the inert pair effect. Due to inert pair effect, stability of the plus 6 oxidation state decreases and plus 4 oxidation state increases. This is about the oxidation state. The next class we can study about the anomalous properties of oxygen.